Hey, what's up, everybody? Welcome back to another Skits Tuts, and today we will be jumping straight into how to make the player move. So, basically, all I did is I designed this little spear, drew some eyes on him, and imported them into the package. Right here, I created an empty, and I drug Smile Face straight in there and made him a child of the empty. Only thing I did for the Smile Face is that I added a circle collider and I sized it to where it fits. He is not going to be in his trigger, so leave that alone. Now, as far as the empty, I added a rigid body, and this will be what we access to actually move the player. I did adjust the linear drag to 1, the angular drag to 0, and the gravity will stay at 1. And I froze a constraint on the Z axis. We won't be needing that in 2D space for the most part. Now, as far as the platform, I pretty much added a tag. I don't believe I went through how to do that, but you just click on where it says tag, add a tag, name it whatever you want. I named mine ground, and that will be important in the code. For the box collider, I used so that the player has something to collide with to keep him from falling straight through. And I actually went to here, and you can create a physics material 2D, and I went with a no stick material. And whenever I created that, I drug it into the box collider 2D of the platform. And this, you will also be able to set the friction and the bounciness down to 0 depending on what kind of play you want your platforms to have. This will come in to play in later tutorials, but anyway, I just wanted to give you a quick indication of how I set this up. And now let's look at the code to see how we're going to get this guy moving. First thing, we have only the Unity Engine namespace. That's all we'll need, and we're going to have to access the rigid body. I named it Mr. Happy RB. You can name your player RB. I like to name it RB on the end to be more specific. Game objects would be GO, rigid body RB, etc. Just makes it easier to read later on. I made this a static boolean is on ground, and that way we know if the player is on the ground or if he's not. It's static because we're going to use this in later tutorials to where right now this is just the ground, but what happens when we have a tile that moves back and forth? It's not on the ground, but when you jump on it, you don't want it to be tagged as ground, so it might be like moving platform or something. You tag it, and basically we're going to put a script on the moving thing, and we're going to access it from that script, so it needs to be static, and it's just going to help us to where we can jump once we get on that platform. We need to determine which direction we're moving, so I declared a boolean is moving right. The player move is pretty much right here. The difference between GetAxisRaw and GetAxis is a smoothing. So basically GetAxisRaw is strictly either going to be a positive 1 in the X or a negative 1 in the X. And GetAxis without the raw, it's going to read everything in between. It's going to be 0.1, 0.2, so you have a smoothing in there. I didn't really need that for this code. It's the horizontal, so that's strictly the x-axis, and it'll automatically read the A and the D key depending if you want to move left or right. We're going to multiply that by happy speed, which is another float that we serialized and we added into the inspector. We multiply it by times.delta time. To actually move the player, we're going to get the rigid body's transform position. We're going to make it a new position, and the vector 2 is going to be the current rigid body's position dot x coordinate plus player move, which is this right here. And we're going to maintain whatever y position we currently have. Then we're going to call the player movement function. And this is where we actually are determining what keys are pressed. Get key is when you hold down whatever the key code is. Get key up is when you release that key, it fires, and it's going to call this function. And the same thing happens for here. We got a get key down right here that we jump with, and that's when you push the button down initially, and it immediately stops firing after you push it down. So it's a one-time deal, space. Since we're not doing double jumps, I went ahead and just made it a get key down. If you want it to do, the longer you hold it down, the higher he jumps type deal, you'd want to get key. So I wanted to show you all three of those versions, the up, the get key, and the down. Alright, so when we call the move left, whenever the get key is called, it's for the duration of the time it's held down. This function, move left behavior, will be called. We are going to be getting the game object, the transform of that, and we're going to get the child 0. And we're going to get the child 0 sprite renderer, and we're going to access the flip X. Now let me show you this. It's pretty cool. It's a good way to flip the player in a direction. So here's the parent. That's what our script is on right here. This is the first child, which is child 0. We're going to access its sprite renderer right here, and underneath is flip and X. So if you look at the screen at the player, you'll notice that he flips. So this is set to false by default, and when we are setting it to true, he will flip the other direction. So that's something cool, and I thought I would share that with you, and it's going to help you out a lot, save you a lot of coding. Whenever we hit the other button, it'll become false. And let me explain this to you. This is just something I did for my circle. It's a cheap animation. It's a cheap way to animate a circle object like I got. So basically he's just going to spin in the direction so it looks like he's rolling like a ball. And that's how you do that. You don't have to use it, it just depends. You can try it, see if it works for you. If not, then I'm sure you'll figure something else out. I just thought it was better than just having a square or a circle just sit there. So how we make our player jump when the spacebar is hit, it'll only run this code if on ground is true. We're going to get the RB, the rigid body, we're going to add force. It's going to become a new vector to 0x 8f. So we're jumping 8 units. The force mode 2D will be an impulse, and that's the type that we're calling. Whenever we let off of the A or the D, whenever it's rolling, in case the player is upside down, sideways or something, this is how you get the rotation to turn back to the quaternion identity, which is basically the way that it's standard. It's going to go back to 0 rotation, and it'll be facing whatever direction it was already rolling in. Works great. It's a pretty cool line of code. You'll like that. Now this is what determines the player. Since the script is on the player, whenever its collider detects the ground, anything tagged with ground is on ground will become true. When we jump, anytime we exit the ground collider, it will become false. And that's how that works. So with that, I believe, let me make sure I got everything that you need on here. I went over the rigid body with you. The angular drag set to 0. Gravity scale, I set it to 1. The linear to 1. The constraints. Yes, I believe that's everything. So we'll run it. Hopefully it doesn't screw the video up, make it lag again. So you can see the rotation taking place, and as soon as I let off of the key, he does face back the direction he's supposed to be facing in. If you notice, I have a pretty decent camera